Hello, Richard here. Today we're going to take a look at another problem on the mini lathe. Yes, another problem. I hear you say, that's a surprise, a problem on the mini lathe? We're going to be taking a look at a problem which is a problem with the saddle gibs. Basically the strips of metal that hold the saddle in place and stop it from wobbling around. We've got a bit of a problem with those. So we're going to be taking a look at that and seeing how we can improve on that. In some of my previous videos, one or two of you have pointed out that when I was taking a cut with the tool, that it was cutting not only on the way into the job, on the in-feed, but it's also cutting on the way back out again. There can be a few reasons that can happen. One can be that there's too much tool stick out and the thing's flexing. Another could be that the work is poorly supported or just too thin and the work's deflecting and bending out of the way. In this case, it wasn't really either of those. It was a problem with the actual saddle gibs. And probably the easiest thing for me to do is show you the problem. So let's have a look and we'll go from there. So what I'll do, I'll show you the symptom of the problem. And what we're going to do, we're just going to take the tool here. We're going to take a cut. I'm just going to hand feed a cut into here. Fairly, well, reasonably heavy cut for a mini lathe. And then when we're done, just watch what happens when I bring the tool back out again and just see how much metal's removed on the way back out. And that's the problem that we need to overcome with whatever fix we do. And as I say, it's probably the saddle gibs is the favourite. But I'll show you what the sort of symptoms are, so that if you've got a similar problem, then hopefully this can help you. So let's take a cut. And as I say, don't worry about so much the tool going in, just watch what happens when it comes out and see the metal that's removed. Okay, so you can see the shavings coming off as the tool was brought back out again. Now, it's not a bad finish on there, to be honest. It looks a little bit rough, but it actually feels very smooth. But anyway, what we'll do now, I'll show you the problem with the saddle gibs, and then we'll look at how we're going to fix that. Now, I've got a dial gauge on a mag base on the bed of the lathe, and what I'm going to do now, I'm just going to rock the saddle. I'm not going to touch any of the other bits. I'm not going to touch the cross slide or the compound. Just going to try and hold the saddle. And let me just show you the sort of deflection we've got on that. So if I pull it backwards, it goes back a couple of tenths of a millimetre, push it forwards, and almost 0.1 of a millimetre. So we've got about 0.12 millimetres on the saddle. I don't know if you can hear that. If you listen very carefully. That clunking is actually the saddle. The gib at the back here is quite loose and it's causing quite a lot of play. Now, that's just holding the saddle. Now, if I then hold on to the cross slide and I move that as well, you can see that adds on to give us about just over, say, 0.2 of a mil of play. And then if you want to have a real laugh, then let's grab the actual tool post. And we'll see how much play we've got in that as well then. So we'll get the tool post and that goes back to, well, let's zero it out, shall we? I can guess something. This is probably zero it with. This is probably easier. So let's pull it all the way back and I'll zero it. And then we'll push it forwards and yay, half a mil. So half a mil of combined play in the whole lot. So it starts at the saddle, gives us a bit. We get a bit more on the cross slide, and then with all of this, yeah, it's all. There's so much spring in this; it's unbelievable. So we've got about 0.5 millimetre of spring from the sort of rearmost position to the foremost position. So what's happening is as the tool hits the job, because this is a carbide tip tool or a carbide insert tool, there's quite a lot of tool pressure pushing the tool off the job. It's not like a nicely sort of honed HSS tool that's going to slice through like butter. This kind of gets pushed back with quite a bit of force. So that's going to be pushing the tool back. Oops, actually, that doesn't help if I press that with my hand. If I press the dial gauge, if I touch the dial gauge myself, then obviously it's going to go wrong. Ignore that. So the tool's going to get pushed off the job. And then when the cut's complete, it's going to spring back a bit and then it's going to take more meat off. So there's quite a few things to sort out here. as you might expect. But this time around, we're just going to be looking at the saddle and seeing if we can tighten that up a bit and reduce the play. So let's remember these numbers, shall we? We've got, let's look on the saddle. We've got from sort of, we've probably got about, that's 0.08 to about 0.2. So we've got about 0.12 millimeters on the saddle. The cross slide, it's hard to tell because that's interrelated with the saddle as well. And then overall, we said we got about 0.5 mil. So if we go for the high score, I could probably just keep going. I could probably bend it, but 0.5 mil. So if we can improve on that, then hopefully we can come back later and see if we've improved on our symptoms of the tool cutting on the outfeed. All right, so I think we've got some stripping down to do. So I started taking things apart a bit now, and we're around the back of the lathe. And if I zoom you in here, you can see that this is the back of the saddle, and you can see the Gibb at the back. The Gibb is this piece here, this piece of steel, high quality steel, he says sarcastically. Now you might notice that this is a little bit non-standard here. When I first got the lathe, this saddle Gibb, the one at the back and the one on the other side, these were just held in with 3 cap head screws, and it was really ropey and really wobbly. So what I did was I basically put in 3 studs. So you can see we've got these studs, and I sawed a slot in there so I could tighten them up with a screwdriver. And these studs are Loctited in. And then I used nylock nuts just to kind of clamp this up in such a fashion that it shouldn't really come loose. Interestingly though, if we look at it, you'll notice, I don't know if you can see this very well, look, it's wobbly. There is no way I left it like that. You know, when I tightened this up, that wouldn't have been loose. This one as well, this washer's actually slightly loose. I don't know if I can get it so you can see that moving at all. Just give it a little nudge. So you see that move slightly, and this one's also loose. Don't know if you can see that moving. Let me just push it back the other way. There you go, just have a watch. So they're all loose, which isn't really going to be helping. This is going to make this flap up and down. Now, looking at some other people's lathes on YouTube, I noticed that quite a lot of you have actually got extra screws on your Gibbs. There's little grub screws in between here, with the idea that you would tighten up the grub screws, which would stand this Gibb off a little bit. So if you look around this end, you can see that we've got the Gibb strip here. And this is really bad. Now, I don't know how well you can see this on camera. I'll try and hold it still for you and see if we can draw it on there. But basically, this Gibb strip here should be horizontal, or should be coplanar with the bottom of the saddle here. This is actually just canted over. So all the Gibb is contacting the bottom by is just this very edge. You know, this should be parallel, and it isn't. And it never will be like this. So that really does need to be sorted out. That's one of the most pressing problems there. So I need to come up with a way of leveling this up. From what I've seen, most people just shim this. So that's something I might do, is put some shims in here just to get it all nice and sort of horizontal. But we'll take a few measurements as well while we're at it. We'll see if we can measure how much play there is in this. I know we sort of got an idea before, but we'll get a dial gauge on it, have a look, see how much vertical play there is. And then we'll sort of see what we're going to do. So in fixing this, I don't really want to make this into a massive epic kind of project. I want to just get this up and running. So I'm sort of planning on doing something fairly quick and dirty on this to get it going. I don't really want to sort of perfect it or anything. Having said that, we'll see where we end up, but that's the idea. So we'll take a few measurements, and then we'll have a little bit of a head scratch and decide what we're going to do. Now, I've got a dial gauge on the back of the saddle. So what we'll do is we'll just pull this down by hand, and we're on about 1/100th of a millimeter there. And then we'll push it up the other way, and we're up to about nearly 11. So we've got about 0.1 mil of play in there, which ties in with what we saw at in the previous measurements. We reckon we had about 0.12. So what I'll do, we'll just hop it over to the other side and see what that gives us. Okay, on the other side, see if I can zero this in a little bit. It's not a very good dial stand, this, so it's quite hard to zero. And we'll get it roughly there. So we're on about 0 there, and then if I relax it and push up, we're up to about we're up to 0.06 of a mil. So we've got about 0.1 of a mil on this side and about 0.6 of a mil on this side. So that gives us an idea of how far out we are. So what I think we'll do next is we'll take things apart a bit further, maybe get the top of the saddle off, take a few more measurements of this and that, and come up with a cunning plan. I got the saddle removed, and I thought I'd have a look at these studs that I put in on the bottom there, because I say I can't believe that they've actually come loose, or that the nylock nuts have actually worked loose either. And to be honest, they're all quite firm on there. You know, if I look at the nuts on here, you know, they're not just loose, they're not going to wobble loose. And the studs, if I just put a screwdriver in one of the studs, you know, there's no play on that. It's not moving, it's not loose. So I don't know why there was so much play on the washers when we looked at it just now, other than maybe things have stretched. Maybe one time when I crashed the lathe and jammed a parting tool under the job and everything moved, maybe it bent. Maybe something actually physically bent. Maybe the stud stretched. I doubt it. So yeah, who knows really what went on with that. Anyway, the investigation continues. I've taken the saddle off and got the Gibbs off and everything as well. And you can see on the Gibbs, actually, you can see the wear pattern on there. You can see how it's worn at each end. And I can actually feel a slight little ridge there with my nail. So it's definitely taken metal off. Whether that was the reason why these two nuts went loose, who knows? This is the one at the back of the lathe, by the way. This is the one nearest the front, and it's got a much more pronounced scoring pattern on it. You can see there's that, and again, there's actually a ridge. So I can feel a slight ridge as it, and basically it was trying to lap itself flush because it was sitting on a corner. You know, if this was the bottom of the bed, then this was sitting exaggerated, but it was sitting like that, just rubbing along. So it's kind of trying to lap itself flush, bless it. Something else has come up with this as well that I'll show you, because I say this is inevitably going to turn into going down a bit of a rabbit hole trying to sort this out. So let me move the camera and I'll show you the next thing we need to think about. Well, I've put the saddle back on the bed and, you know, just continuing our investigation as to what we need to be doing here. And turns out this actually doubles up as a handy Morse code key. Anybody know the Morse code for SOS? That means my lathe's in trouble, please send help. It's rocking like Noddy Holder. Yeah, this is not so good. So what we'll do is we'll get some feeler gauges and we'll have a look and see just how far out that is. So let's have a look. All right, so then place your bets. What do we reckon on how far out that is? How far out does that sound to you? I reckon we'll try 0.5 of a mil. And no, it's not 0.5. So what else? Let's try 0.2. No, it's better than that. It's better than 0.2. So, you know, it's not as bad as you might think. I mean, it's bad enough, but you know, let's try. Where's my 0.1? 0.1 millimeters. So 0.1 goes under there quite comfortably. It's a little bit. Actually, I can feel it sort of binding a little. So let's put some pressure on this side. I'd call that 0.1 of a mil under there. So let's slide it along a little bit. Try again. Less than 0.1 there. We'll slide it up a bit further this end. And less than 0.1 there. So it's worse in the middle. In fact, it doesn't. In fact, I can't even get that under now. So maybe it's slightly less than 0.1. It does just want to nip under there. Let's try, say, 0.8 of a mil. A couple of these together. So yeah, 0.8 is just nipping under there now. And it's just going under. So we're a little bit out. And interestingly enough, that sort of corresponds with the amount of sort of play we had. Oops. We're talking about just under 0.1 of a mil of twist on that. And we were getting a 0.12 mil of play when we rocked the saddle backwards and forwards. So that could tie in. So we need to think about that. We can't really just do things with the Gibbs, if we don't sort this out as well, that's just not going to be conducive. So I need to think about how I'm going to flatten this down. Now, I could actually scrape this surface, but that would mean we'd have to basically lower one end of it. So this end is the high end. So we'd have to lower this end down, making sure it's all level, but that then might throw it off. If I remove material from this end, then it's going to basically, I'll exaggerate this, but it's basically going to do that, which isn't going to be good news for the V's. So what I might do is I might just sort of stone these off, clean them up a little bit, maybe put some blue on there and sort of just see how it looks, see what sort of an imprint I get on the key, on the V slot, on the V groove, see how far out that looks. If that's out as well, then, well, will's me oyster and I can do what I like. So I need to have a think about that. It would be nice to redo this. It would be nice to scrape that in because it's just such a, let me just show you that surface. I don't know if you can hear this. Let me bring you closer to the microphone, see if you can hear this noise. Yeah, that noise is the sound of my fingernail scraping over this milling here, which is quite rough. So that could do with being smoothed out a little bit. So I think that's really the main thing. Another thing I want to do as well is measure the thickness of the bed along here. I'm going to clean this up a little bit, and then we'll run a micrometer along there and see where we're at. Let's just have a quick look at that. All right, let's see. We've got uniform thickness on the bed here, so let's take a reading of that. So 8.4, 8.45 there. 8.46. And 8.51. Let me just recheck the center again. 8.45. So we're about sort of 6/100ths of a millimeter across that distance there, which is all right. I can live with that. It's not the cleanest of surfaces underneath, so again, it could benefit from being cleaned up, but I don't think it really warrants it for that far out. So probably time to clean this up a little bit. We'll take the studs out, deburr it, clean it up a little bit, get it on the surface plate, and then we'll sort of work out where we are. Maybe sort of blue up a few bits and again, work out a game plan. See you in a couple of years when it's done. I've had a bit of a potter about with the saddle. Been doing some measurements, got it on the surface plate, and just trying to work out what approach to take in fixing this up. Nothing is really kind of straight and level on this at the moment. These are the two sort of areas where the Gibbs seat, and they actually could do with being parallel. They could do with being coplanar in the same plane, and they're not. These 2 points here and this point are on a level with each other. This one is about 0.1 of a millimeter high, so this is slightly high. The ways on here, they're a little bit bowed. This top surface here, this isn't a bearing surface, but it does seem to be quite flat. It's within a few hundredths of a millimeter in flatness. Now, whether that actually is in a parallel plane to where the ways are supposed to be, you know, whether I can use that as a reference or not, I'm not sure at this point. I can't really measure the V. I don't have any way of really sort of measuring and referencing that. I know that this plane here that basically sits on the ways at the back, this is out of whack. We need to level that up. So it looks like what I'm going to probably want to do is just get this sitting flat on the bed so it doesn't rock, and so it's nice and level. Whether I then carry on and work on the ways, I may do, I may not. We'll take a view on that. Like I said, I don't want to turn this into a big sort of epic project of perfection. I just want to get this thing working a lot better than it was and really focus on getting the Gibbs sorted out and also stopping this from rocking into the bargain. So we can always come back to it at a later date. So I'm not looking to do this all in one go necessarily. I'm going to work on basically getting this to stop rocking on the bed. And I'm going to assume that the ways are level because I don't have any way of fixing them if they aren't. So me assuming that is a way of just saying, okay, well, whatever. I will assume that they're level. And what I'm going to do, I've got some engineer's blue. I've got some of this Stewart's micrometer greasy oil blue that gets everywhere. I've got some of that on the bed, and I'm going to indicate this on the blue. So we'll put that on there and give it a little bit of an imprint. And that will hopefully tell us where we are now. I'm being careful not to rock it. I don't want to get any blue on this bit because I know it's going to rock if I do. So we'll just move that gently a little bit and see where we pick up the blue. Give us an idea of where we are. And if we look at that, so we've picked up blue all the way along that V, so that's good. That means that that's rubbing. Hard to see on this one. It's picked up a little bit on that end, and it's picked up a little bit here. Tell you what I'll do, I'm just going to put a bit more blue on to see if we can get a stronger imprint, and then we'll have another go. Alright, so we got some more blue on there now. Let's give that another go, see if I can get a better imprint on there, just to give me an idea where we are really. So lower it down this way. Let's move it around a little bit. There we go, that's better. So as you can see, we're picking up blue here. So this is all low. Well, low here. If you have it that way up, it's obviously high. But we've got a spot there we need to take down. And the V groove, hopefully you can see that okay. The V groove is blue all the way along. Now that's quite a thick coating of blue on there, but that's a good sign. You know, we got a good bit of contact. So what I'm going to do, I'm going to basically work on scraping this. I'm going to scrape this down. And what we'll do is on this piece, we'll step scrape it. So we'll scrape it down at this end, and then we'll scrape, say, this much, and then we'll scrape this much, and then the whole thing. And that should sort of angle it down this end a little bit. By scraping this, we may then find that we lose the contact here somewhat, because if we're basically, what we're doing is, if we're taking this edge up, then this is going to basically tilt down, if I exaggerate it, which means that the V isn't going to contact in the same way, but we can just re-scrape that as we go. So that's the plan. We'll give it a bit of a scrape, and then we'll see where we end up. So I've given this a few passes now. I've scraped it a couple of times across here, mainly focusing on this bit, which was the spot we needed to get down a little bit. I don't know how we can see that on the glare on the screen, but you can see now, hopefully you can see that anyway, we've got contact at this end, some few patches here, and we're starting to get a little bit of contact over at this end, whereas before there was none. So that's good news. We're starting to bring it in there. So basically all I'm going to do is put it back on the bed, blue it back up, scrape the blue bits off, re-blue it, scrape the blue bits off, and keep going until it's sort of a uniform pattern. And we'll hope, as I say, that the blue sort of remains uniform over the V. It may not, but we'll tackle that in a moment. So let's do some more scraping. Right, another probably 10 passes or so just now. Hopefully you can see that we're getting more of a blue spread across the top edge there, and along here it's starting to even out and creep along here a little bit. This is telling us basically it still needs material coming off where the blue is here and here. This is still low, and again, when I say low, I mean as we're looking at it here, you know, it's not actually low, because it would be high if it was that way up. Anyway, you know what I mean. So I'm not worrying about the V's at the moment, just going to focus on this. But you can see we've got this even spread across there already. So if I put this back on here, one thing you'll notice, we no longer have a Morse code key. That's already taken the rock out of it. So I'm just going to carry on until I get a much more of a bearing surface, and then we're pretty much done with that. All right. Well, I've been scraping for a little while now, and just taking it very slowly, very steadily. And we're starting to get somewhere now. If I grab my pointy stick. Hopefully you can see this on the video. I'll try and get rid of the reflection as much as I can. I'm getting blue now over most of this area. Let me just wiggle it around a bit. Hopefully you'll be able to pick that up at some point. That shows I've basically got this pretty much level, pretty much flat, and I just need to focus on knocking down the blue bits now and get a little bit more coverage, but that's probably all right as it is, really. And I've also started scraping in the V's a little bit, because I noticed that the blue lines were starting to narrow up a little bit on these. So they've had a little mild scrape. You can see on this one, hopefully, that it's picking up the blue at the top edge, but not so much deeper down. So I need to sort of keep knocking the blue back a little bit to try and sort of counter for the fact I'm lowering this end, and everything needs to just cant over a little bit. So as I lower this, you can see it's bearing more here. So just need to knock that down a little bit, and we're sort of getting somewhere. But one thing you notice with this is that when you start to get it flatter and you start to get a scraped finish rather than just a pure flat ground finish, it actually slides a whole lot better. So when you put it on the bed, it actually slides. You can feel it slides more easily than when it was all just sort of flat milled and flat surfaces. So it's a really nice finish. The scraped finish is really good for sliding surfaces. So more scraping. I'll see you in a bit. Right, another 40 or so minutes worth of scraping later. We've got this. I've got a fairly good coverage pattern on this slide now. Quite happy with that. It's not perfect. It's not perfect scraping, but you can see we've got blue over the whole surface. That should be a whole load better than it was. And on the V's, we've got coverage on those. Again, there's a few little spots where there's nothing, but I'm not going to obsess over that. I think that's, they're uniform all the way along their length. There's a few little bits missing, but that's a whole load better than it was. So if we just pop this back on here, it's nice and flat now, nice and solid. So the next thing to do really is going to be to try and clean up these Gibb faces. This is where the Gibbs are going to fit. So if I'm going to put shims under the Gibbs, which is probably going to be my preferred solution, I want this to be flat, and I want it to be parallel with this face, well, this face here on the ways, which would mean it's parallel with this. So at least with this now, I could get this on the surface plate, level this up so that this indicates 0, and then get this scraped so that this indicates 0, and then match this one to match that one. That should give me near enough the right sort of ballpark area I want to be in. So that's probably my plan at the moment. Scrape these faces in. Look at probably seeing about sorting these out a bit as well. I don't know whether these can be scraped. They're probably steel, so they won't scrape very nicely. But I can probably clean them up a bit anyway. As for the top surfaces, not sure yet. I don't really want to get too involved in these at this stage, because I can do these later if I need to. We'll see how we go. We'll see how we get on, see how fed up we get with doing this other stuff. Not that we ever get fed up, do we? It's what we enjoy doing, but we reserve our right to complain about it. Right, I think we're going to call that end of part 1, and we'll carry on in part 2, so stay tuned for that.